All right, good morning, everyone. So today we have a new script that we're going to be working from. I pushed that to GitHub this morning. So if you want to bring that to your computer, it's called 0422 Imagery Processing 2017 Partial. And while you do that, I want to quickly go fetch my power cord, because I think I may be running out of power sometime in this class. So I'll do that, and then okay, if you just bring that in, it's just a script. You do not have to create a new project, new folders, all that. Just bring that script into the code folder of the current project, the 14 satellite, and then we're going to be working through that. I'll be back in a second. All right. So before I get started here, I just want to mention something that I noticed from last class, and I'm sure all of you had this happen, but I just want to point out. So let's see here. So I'm showing you, yeah, writing. So right now I just pulled the script from last class. And if you remember, we basically here brought in our boundary, did a bounding box, determined some of the parameters to pull the imagery. And then we created this. So this is where there's a little bit of difference in the code from what you have and what I updated. So here we were creating that export folder, which was just like including the site name, the item name, the asset, and then some of the dates. So it was creating basically what I'm highlighting right there. And then when we were making the call to the Planet API, we were saying to save on this folder here. So class cotton, PSC, and so on. Even though we have created a directory inside of the data folder. However, when we are making the key or the call to the Planet API, we give the export folder object as the output place or where we want this to be exported. And if we were to print just export folder, it would come back as only starting here. What that made is that you did create a folder in your data, a subfolder in your data folder with the name of this, right here because we created that directory using this command. However, whenever we got the images from Planet, they were actually being exported to your code folder. I think you may have noticed that. A quick fix, I guess, from that one is just for you to copy and paste this folder from your code folder into your data folder. That would be a manual fix. But then to fix this moving forward, as you recycle this code, I just added an extra paste 0 here with this and a closing parentheses at the end, just so we also add this /data to this path. So whenever you make an API call again to Planet, it will truly export to your data folder rather than your code folder. So again, the difference was just adding this extra line and then making sure you close that opening parentheses of the paste 0 function at the end. So that was the fix, I guess, to make sure that this does get exported to your data folder and not to your code folder as it happened last exercise. All right, I mean, you don't have to rerun anything here. I just wanted to show you. And so you can have the proper code for the future times use this script. All right, so let's start with today's exercise. So if you remember, we pulled, I think it was like 47 images for the growing season in 2017 for this one field. And those were the images that matched our limit of less than 20% clouds. So now we are going to process this imagery and try to learn from it different aspects. So one thing, I guess, I mean, there are many uses that we can do with this imagery. So if you're collecting season data, this is your study, you're collecting a lot of data. You can use this remote sensing data here to train algorithms, to train machine learning algorithms of whatever sort you may have, as long as you have a GPS coordinate of where you're taking these measurements on the field. But more generally, and maybe perhaps more connected to this class, which we're not doing machine learning in this class here, there are two main goals that we can achieve here. So one of them is monitoring, right? So we are pulling data from the archive, but imagine that this is a field that you're tracking this growing season. So you have the potential of getting one new imagery every single day. Of course, there are going to be cloudy days where you don't get the image, but you have the potential of getting one image per day. Now imagine if you have many fields, you will never be able to fly many fields every single day with the drone. That's just not even possible, right? I mean, unless you have a lot of money to pay someone to do it for you, but on a efficiency, in an efficiency way, you're not going to be able to do that. So having satellite that's doing that for you can be a really important asset, especially with 3x3 meter spatial resolution, which is what PlanetScope gives us. So if it is a current growing season, you can use it for monitoring, right? So you can perhaps identify the onset of stress before you can visually identify in the field. So if you go to a field, you may not even be able to see that stress yet, but satellite imagery can give you that potential of monitoring in field. And also zoning. So one thing that I'm going to show you here in just one other application is we can use past archive data of a whole growing season and trying to relate that to yield zones. So in crops where you do not have yield monitor data, we may use imagery to actually provide us some idea of different yield zone potentials in the field. Even if you don't have yield data itself, it's going to be, green NDVI or some other remote sensing information, but we can still learn from it because for the most part, crop vigor is going to be associated with yield. Perhaps cotton is not as straightforward. That relationship is not as straightforward, but for most other crops, the more vigorous plants you have, the more yield you're going to have in the end. So we can use imagery a longer growing season to try to identify EO potential zones, even if you do not have EO data spatially varying in that field. So we're going to explore both of those today and probably into Wednesday as well. So go ahead and run the first chunk here, which is just loading our packages. The first thing that we do here is bring in the boundary. I already left through all the code because, we've done this many times. So I would hope that you already know how to do this, if not given the code. So the boundary is just the boundary of our field. Now, what I want to show you is what I would do on one image. Like, how would you import one image? How will we process one image? We're going to go through that process first. So if you come on the next chunk here. Oh, you know what? Let me just share my complete script on my other computer. So I have my cheat sheet. Okay, so I guess before we import that image, I just want to come to the folder that we saved all of our files from Planet, just so we take a quick look at it. So yours may be under the code folder if you did not move it manually. I already moved mine manually, so mine is on data, the class cotton PSN. Just want to open this. I know it's kind of small if you're here in Athens to look at my screen, but so if you look here on the first file, so 2017-04-21, that's the date of this first image. We have 1, 2, 3, 4 files with that same name, where we have an XML, we have a .tiff, another .tiff, and a JSON. So these files here are telling us different things about this image, this one single image. What we're really interested in is on that analytics or analytic MS surface reflectance clip. That's the actual image that we want to bring in and analyze. So let's go ahead and first read in this TIFF file and look at and explore it, see how that looks like. So if we come back to the code here, okay, so it is a .tiff file in my file system. What function do I need to bring in this file into R? Let's see, Kumar, what do you think?
I'm not sure right now. If we have not bought it, I guess.
I think we haven't used too many of those yet. So maybe we can think of it as, what is a .tiff file? What type of geospatial file is that? Doug, what do you think?
Is it still a shape file?
So it's not a shape file, it's not a vector, right? So a vector would be, yes, read stars, right? So a .tiff is a raster file type. So because of that, we want to bring in, we want to use read stars for that. So let's go ahead and use here read underscore stars. And let's navigate to that image. So open and close quotation marks. If you did move your images to the data folder, then the code I'll show you is going to work. If you did not move and it is in your code folder, then you don't have to get one level out. But in my case, this folder with the images is in the data folder. So I need to get outside of the code, / go inside data, then go inside of that folder that we created, the class cotton PSN. And it's a long name, but we can just hit tab again, and it's going to be this second file here, at least that's showing to me. So 2017-04-21, 15-30-46, 10-44, 3B, analytic MS, SR, clip.tiff. So that's the one we want to bring in. Just read that. it should have popped up on your environment. And then we can just print it to take a look. So this is a stars object, so it prints differently from a SF vector file type, and or object type, and I'll walk you through some of the differences. I think we've seen a few times, maybe not too many, but we've seen a few times raster files and stars objects in this class. So it gives us here a statistical summary of this very long name that right now doesn't make a lot of sense. And if you come on the second panel here, it has X, Y, and bands. So this is a difference that I do want to clarify here. So previously, when we had stars objects, let's say, if you remember when we did interpolation, the immediate product out of interpolation is a raster object. So that raster object, let's say, had interpolated yield, and that value would appear on the first panel here with statistical summary. So now this is coming from a stack of rasters where each layer of that stack is a band from the satellite. So we have here on the second panel, on the dimensions here, we have an X dimension, a Y dimension, and then a band dimension, which is saying that it goes from value 1 to 4. If you remember, this satellite that we were pulling has 4 bands. So really our band information are all contained in this dimension. And this perhaps is a little bit confusing because if it is in the dimension, it's not directly evident how to use that information if we want to calculate other things out of it. So what I want to do is bring the bands that we have out of this band dimension so they appear here in this summary instead, which makes them more readily available for us to use. So that's basically what we're going to do here on the next chunk. So my goal on the next chunk here is going to be to first pull out these bands from that dimension and actually into the main level of the stars object, and then calculate green NDVI with those bands. So remember, we have 4 bands. It's blue, red, green, and infrared. So with those, we can calculate different indices, but one of them that I want to focus on is green NDVI. All right, so if you come here on the next chunk, let's start doing that. So give the assignment symbol. The object above we named image. So let's start with that. So the first step here for us to bring those bands outside of that band dimension and into the main level of the stars object is going to be to use a function called split. So we say split and then the current dimension name, which is called band. If we run that, and now I want to print this image W object, notice that I don't have a band anymore on the second pane. It's just X and Y, so I don't have a band dimension anymore. And if you go to the first panel here, you have the actual 4 bands pulled out for us in the main level of the stars object. So blue, green, red, and infrared are the name of those variables. All right, so now that we have direct access to those bands, I want to calculate green NDVI. So let's go ahead and give this a pipe. I want to create a new column here, so we're going to use mutate to do that. I want to call this GNDVI for green NDVI, and then we're going to give it the formula here. So I'm going to help you out. So the formula is going to be in this way, where we're going to have a numerator, and then a division symbol and a denominator. Can anyone help me here of what goes on the numerator here if we're calculating green NDVI? Eva, what do you think? Something minus something, all right. That's fair. Yes, that's it. So NIR minus green on the numerator. And notice that I'm using these names here because that's how the bands are named, right? So if the names were been uppercase NIR, you would have used uppercase NIR in this case. So we're just following the naming convention of what's in there. All right, so we do NIR minus green divided by, Nelisa, what do you think? NIR plus green, that was easier. So yeah, it's just the two bands. So if you remember, any normalized difference vegetation index, so any NDVI type of index is most of the time going to be using near infrared, so the band, one band from the near infrared part of the spectrum, and then one band from the visible part of the spectrum. In our case here, we're using the green as our candidate for the visible part of the spectrum, but the original NDVI used red instead. Now, why do you think that I am proposing we use green NDVI instead of NDVI itself? What do you think, Briswell?
I think you mentioned that due to a lot of vegetation, when you use NDVI, it will oversaturate the pixels. So using the green NDVI will help overcome that issue.
Right, that's correct. So what Uswal was saying here is that we're using the green, not the red, in this place of the equation, because the red band saturates when we have larger vegetation biomass. So if you have a leaf area index greater than 3 or a higher concentration of chlorophyll, the red band will saturate. You will not be able to differentiate healthy from very healthy if you have the red band. And the green band gives you back that sensitivity. So that's why we're using green NDVI. All right, so if we run that and you print it, now you have on the first panel your bands and then also your vegetation index. You know, we really could calculate many other vegetation indices. For this class, I'm going to stop here because that's not the goal, is not to compare different indices. But if this is your research, this is where you would develop more indices if you need it. Now, I really, at this point for this exercise, I really do not care about the bands. I just want to move forward only with green NDVI. So let's do a select here and only select that column. So dplyr select GNDVI. So we just move on with that variable. So if you print that on the first panel, we're just going to see green NDVI after that. All right, so let's quickly explore here what this is. I left you the code already, so it's called, just using a map view function so we can interact with it. You can just run that and we can explore this a little bit. I do want to come here, go on the stack symbol and just change the base map to Esri so we get the satellite imagery. So we can tell this is our field, it's in the right place, it's properly aligned, so everything is great. One thing to notice here is that remember that we were asking for the imagery based on a bounding box, right? So that's why we have all the pixels around the bounding box and not just for the field. So that's something we're going to have to address when we get to that part of it, but I just wanted to remind you of that. Also, the base map that we're seeing here behind us is a satellite imagery unrelated to our data, right? This is, I don't know what's the exact source of it. There's a list here of where that could be coming from. But I'm saying that just to, if we look at the scale of green NDVI, a lower value means lower vigor or even no plants at all, right? It could be just soil. And a higher value means more vigorous plants. So if we look here, it's kind of, when I was checking this, I thought it was interesting that on this image, at least, the field here looks, overall, it has very low green NDVI. And that's because, again, this image here, if we look at the date that it was collected, it was 2017-04-21. So basically yesterday, but in 2017, right? So you wouldn't expect it to have a lot of vigor of the crop, at least if this is a summer crop, like corn or cotton or peanuts. You wouldn't really expect to see a lot of greenness out in the field yet, but we do see higher green NDVI values here, also on the boundary, like right outside of the boundaries, maybe here as well. I'm guessing, and this is where looking at the base map behind it may help us understand. So here, it could be trees, it could be like a grassy way. Bring back ours again. So we see over here, these are trees. So, they are already showing greater green DVI at that point of the year. And also on the west side as well, we have a tree line there. So that's why those parts of the field are more vigorous at this point in the imagery.
Hey, Dr. Bastos,
Yes.
we, down in Tifton, we both got an error just trying to get that map view to show up.
What does the error say?
Error in normalized path. Path dot expand,
The same.
path, / must work.
Okay, all right. Okay.
Something on my OneDrive.
I think this is something about windows and length of paths. So Neva is saying here she's had the same problem today, I guess, and also in the past where, yeah, I guess we're having these long paths, which I guess on my side, I'm using a Mac. It doesn't complain. But if you are using Windows, it may be because of the path length. So if you want to, I guess if you want to fix that, you feel free to just rename this whole folder here to, is that what you did, or? Oh, okay, so the script file name, okay, got it. Okay, so Neva is saying if you rename the script to something shorter, you can just leave like 0422 if you wish. So the script file name is too long. If you just try to rename the script to just a shorter name, that may fix the issue. All right, well, if that doesn't work, let me know, guys. I don't want us to spend a lot of time on that just because we're just visualizing here, but I do want you to be able to get this right eventually. So if that doesn't work, then we can talk after class. All right, so we just did a very quick processing or wrangling here, which was to bring the bands out to calculate a vegetation index. And we just did that for our first image. If you remember, we were able to download 47 of them. So now what do? Do we just copy and paste the scope 47 times and then edit it? Well, you could, I guess, but that's not what we're going to do. I want to show you a way to automate this process a little bit more so you don't get boggled down by copying and pasting code. So here's what I want you to envision. So we have this folder here with all the TIFF files that we need to bring in. And actually, if you look closely, we have two different types of TIFF files for the same image. I'm not going to bring in the UDM2 for us to see what it is. If you want, you can do that on your side, but that is not what we want. If you bring that one, you're going to realize that's not what we want. What we want is all the images that have this pattern here of 3B Analytics SR clip. All of the ones that we want have this pattern, and they all TIFF files. So we're going to use some code here to first look for in that folder all files that have this pattern. And then we're going to have a list of the name of those files first. And then we're going to use that list to read each one of those items in R automatically for us. So the first step here of that automation is going to be to create a list that contains all these files here for us. So if you come to the next chunk, give it the assignment symbol. We're going to use a function here that's called list.files from base R. And it has a handful of arguments we're going to change. The first one is called path. You can say path equals to, you can give it open and close quotation marks. I want to navigate to that folder. So in my case, again, I need to get outside of code. So // I need to get inside data. And then if I hit tab, I want to get inside of that class, cotton, PSCene, orthoanalytic for BSR, and so on. I want to be at that level of that folder. This is my path. I'm saying go inside of this folder here and look for files there. All right, so the next argument we're going to change here, if you give it a comma and hit return to break the line, I want to give it a pattern for it to look for. If we only had one TIFF file for each date, all we needed to do would be to give it to say like this. So this basically is saying in that folder, look for every file that ends in .tiff. However, if we do this, it's going to capture both of those TIFF files of the analytic and also the UDM2. And again, we do not want the UDM2, we just want the analytic. Because of that, if we look, so what I'm going to do just to make our lives easier, if I just come back here and hit tab again, you can just select that first 2017-04-21 analytic ms sr clip.tiff. You can select that just so we get that pattern from the file itself instead of typing out. But what I want to bring here is if you start on the A of that analytic, you can just copy until the end of the TIFF because that is the pattern we want to use. And you can just paste that inside of this pattern here. And then don't forget to add a $sign at the end of it. Before we keep going, I do want you to go back to the path and delete that file name from there. Because remember, the file name I just used so we could copy and paste that pattern, but I don't want you to leave that one file in the path. And then it has, if you just give it a comma here, it has a couple of other arguments we want to change. One of them is called all.files. We want to say true. And then the next one is called full.names. I want to say true as well. So this is how it should look like. So on the path, I want you to stop at the folder level. I don't want you to select any single file. I did select a single file so we could copy and paste the pattern, but remember to delete that file afterwards from the path. On the pattern, we wanted to say analytic ms sr clip.tiff $sign. This is the pattern we're looking for. And then all files equal true, full names equal true. If you run this and you print this object rast list, is going to be a list. So it is not a data frame yet, but it has identified every file in that path that has this pattern of analytic ms .tiff. Right, so this is just a list with each item of this list being one of the files. If you go all the way down, you're going to see there are 47 files, which each one represent one of our images. And just to explore here, so if you get the length of this rast list,
Dr. Baskins.
yes.
Check the code again. Again, I got a character 0 whenever I tried to print the RAS list.
Okay, so maybe okay, so you were able to navigate to this folder on the path?
Yes, sir.
And then on the pattern, did you add the $sign after TIFF?
I think you're getting the code in the data folder.
Oh,
Just go to the code folder.
Yeah, so if you did not move, so again, from last class, when we brought the imagery from Planet, the way that I gave you the code, it was actually exporting to your code folder, which is like, it was not what I intended, but it is what happened. And so if you did not manually move your images from the code folder to the data folder, they're still in the code folder. So that means you don't even need this part of the code here. You can just start here because this folder is already in your code folder, which is where the script is as well. But if it did move manually to data, then this is what would work. You're getting 0 as well? Did you-
So I moved it over to my data folder and it's still giving me that error.
Is that the same for you as well? Did you move to the data folder and still giving you? Okay, so let me check Ujwal here because it's gonna be easier to check here in Athens, and then if I can identify the error, I'll share here. So give me just. Did anyone else here in Athens not being able to?
I tried like I open my one for code and work it. Open your files and see where the images are. It will.
Yeah. I mean, they're in my data folder. Or like they're,
Okay, open the data.
Yeah.
We have a bunch of those. Okay, do you have like three files with
Oh, I think you have an extra pass here. On the pen. All right, so, in the case of Uzbal, which may not be the same case for you, Clint. So he had an extra S here. He had analytics plural, whereas the correct is analytic without the S. So, you know, if you typed the pattern instead of copying and pasting from the file as I showed, then make sure that whatever you typed exactly matches the pattern in the files.
Dr. Bastos.
Yes,
and I was able to get it. I just had a typo.
okay, good deal. Yes, Rolando.
So I did not move them. I'm still have I have a file on data, but when I click tab, it says not available. So I still have them in code. So I just went in and dragged them from code. So will be the same path after
So are you saying that the images are still in the code folder?
they're still in the code folder. I
Okay.
created another file and it's in data, but the images are not there.
So if the images are in code, then you just, if you leave it like this, I think it should work. Because the script is in the code folder, and if your data is also in the code folder, then you don't have to get outside, right? Outside the code folder. So this should fix it. If that's your case.
Okay.
All right, so well, let's keep moving here. So if the code worked for you and you print rest list, again, it's going to be the list where each item is one of the files. If we ask for the length of this list, it's just going to return how many items there are, and it returns 47. That's because we have 47 images that we pulled from Planet. And then if we just print the first item of this list using this double bracket notation, just so we can see again the name of the path and the file itself. I do want to take a quick moment here for us to understand what this file name means, because it's a pattern that Planet uses, and there is meaning behind this pattern. So it's going to be important for us to understand, so we can use this to create some metadata out of it. So the first file here, this is the name of it. I'm just copying from the path that I printed above on the rest list bracket notation 1. This is the name of the file. So the first component of the name is the date of acquisition, right? So 2017-04-21. So 21 of April of 2017 was when this image was acquired. The 153046 is the acquisition time in hour, minute, and seconds. And then we have the 1044 on that name is the acquisition time in second hundredths. The 3B is the product level. The analytic MS is the band product. So analytic multispectral, that's what we wanted. The SR is the reflectance type. So in our case, surface reflectance, that's what we wanted. And then the clip is just saying that it was clipped to an area extent. So these are all metadata about this file that are right in the file name. There are more metadata in the JSON file that is associated with this, but for what we need to do here, I'm not gonna explore that. Okay, so now we have all of our files that match the pattern. So the ones that we want to read in, the 47 images in a list. I know the path of those files. Our next step here is gonna be to create a data frame where imagine that each row of that data frame is gonna be a different file of these ones that we have in our folder. And so we're gonna read in those files, but for us to be able to make sense of what date is what file, we also have to create a new column with the date. So we know date X, this is the image, date X+1, this is the image, and so on. So we can connect the imagery, the TIFF file, with the date of when it was acquired, which is going to be important for our analysis to know. All right, so let's get into this next chunk here. We're going to be doing, so if we have not, in this class at least, we have not done this a lot yet. So I'll try to make sure to walk you through the process slowly. So the first thing that I want to do here is give it the assignment symbol. I want to create a data frame. So let's use the function data frame. And I want to call this the name of the first column as source. And I want source to be equals to that rast list. So the list of raster paths that we have here. If you run that and you just print all images W, this is what we get. It's a data frame with 47 rows because we have 47 items in that rast list, one for each one of the files, where this is the full path, including the folder and the file name to that image. That's all we have here at this point. All right, so if we look at the full path of any single one here, so let's just do all images, $source, double bracket 1, just so we pull the first one, we can look at the full name rather than being abbreviated here when we print. So this is the full name of the path. So the full path for this first file here. Now we just talked about that the first part of the name is the date, right? Now I want to create a column that tells me that date and not just have this only in the file name. I want to have a column with that information. There are different ways we could do this. I will show you one of them that I think is more reproducible across different sites as you pull imagery from different sites. So one thing I want you to notice, and this is just like the way that I arrived at this answer was just inspecting that file name. And I was thinking, okay, so if this is the date, there are ways I can tell, I can say, hey, just give me this in this whole string here, I just want the names or the characters between this and this. So let's say if this is position, if the 2 here is the 50th character in this whole string, and here is the 58th, I could just say, give me just between the 50th and 58th. It would just pull this number for us, and that would be our date. However, if you change something here on the path to that file where we actually created based on the parameters that we use to pull the imagery, maybe just one extra character in any part of this name. So imagine that instead of a field name class, instead of having a field name of class cotton, if I just had cotton, now this position here changed, right? This is not going to be 50th to 58th, it's going to be shorter. So for us to not be relying on every time coming here, looking at this and see what position is these numbers within this whole path, we can make things a little bit easier by noticing that on this entire string, even though there are one forward slash here, one here, and then there's two forward slashes here that separate the path to the folder and the file name. So I can use this to basically say, hey, everything before the double forward slash, I don't care about it. Just keep what is after it, which is just a file name, right? So that's what we're going to do here. If you give it a pipe, we're going to use a function called separate, where we give what is the column that we want to separate. So that is this column source, the one that we just created with the RAS list. And then we need, because we're going to use the separator, so sep is going to be equals to quotation marks double forward slash, and there's only one double forward slash. So it's going to find the forward slash and split it, right? In this case, we only have one occasion that forward slash happens, a double forward slash happens. So we need to say, what are the names of the two columns that I want to call the left side and the right side of the double forward slash. So we do that by using this argument called into. So we say into, and because there's one forward slash, meaning there are going to be two splits, one to the left, one to the right, we need to give two column names. We're going to use the C function for that. The first component there I want to call path. The second I want to call meta. And then lastly, I want to change an argument called remove. So remove, the default is true, meaning that after separating, it basically removes this column called source. I want to set it to false because I still want to have that source column for us. All right, if you run that and you just print all images W, now we have three columns. So we have the source column as we had before. We have the path. So let me just print the first path here so you can see the whole thing. So path now has everything that we had on source to the left of the double forward slash. That's what path is. And now if I just print, instead of path, I print the first meta, it's going to be just the file name itself. Right, so now we have three columns, one with the full source or the full path to get to that file. The second one is just the path without the file name. The third one is just the file name itself. Now I can come to this meta column where I only have the file name and say, give me positions 1 through 1, 2, 3, 4, 5, 6, 7, 8. 1 through 8, this is always going to be the date, regardless of what field you're doing, regardless of what site you gave in the previous script. This is going to be independent of that. So let's go ahead and do that last line of code, and then we'll stop here for today. So my next goal here is to go into this column meta and just get those first 8 characters, and that's going to be my date. So if you give the pipe, we're going to do a mutate. I want to call this new column date. I want to say equals to. We're going to use a function called, yes.
Dr. Bastos, I just noticed mine on the meta column is a bunch of NAs, but I looked back at the file name. It doesn't have the double forward slash prior to like the date.
Okay. Let me think about it. So if you're, let me just pull the first REST list again and look at it. So here, if you just have one forward slash right there, let me see, how can we fix that? So maybe in this case, we're gonna have to do something else on your side. So, well, let me ask this. Is anyone else having that issue? Okay, Sidiva saying yes. Anyone else not being able to have a meta column? with values?
Yeah, I had the same issue here also.
Okay, so let me do the following. I will show you here what I would do next. If your code is working, and if it's not, then we can connect after class and I can help you there. So if your code worked and you had meta here, we want to ask just for those first 8 strings, which we're going to use or first 8 characters, which you're going to use a function called str_sub, where we give the column name, which is meta, and then it has a start and end position. So in this case, the start position is 1, the end position is 8, because 1 is that first position of the 2 right there, and 8 is this last position of the 1. So if you run that and print it, you go all the way to the right, we're gonna have just the date in a column. Yeah, no problem, Niva. So I will, let me stop here. Let me get everyone's attendance. I know we're over time a little bit here. And, attendance, April 22nd. All right, so make sure you claim your attendance. If you need to leave, you're dismissed. I just want to say here before, to be included in the recording. So if you leave, you can catch up later. So if you're having issues with this code right here, I think it's coming from the fact that, I mean, I'm actually not quite sure why I have double. Let me look at my previous code. So the code that we used to pull the satellite imagery perhaps is related to that. Maybe on my path, I had an extra /. Not sure. Or perhaps it was a difference of, perhaps in Max, it adds the couple, the double. Yeah, that may be it, because you didn't have an issue, right? You did not? Yeah, and Uzwal also didn't. Well, Sundays.
Yeah, I have a Mac and I have a double / too.
Yeah, so it may be a difference of operating system. So if you have, I mean,
That's the right way.
regardless if you have Windows or not, if you have the issue, let's connect and I can help you out. Basically, to make things a little bit more straightforward for this case, what we're going to do, if you have a Windows and you have issues, is we're just going to skip the separate and we're going to do this instead. Go straight into the mutate using the str sub. The thing is, you're going to have to find on that whole string, what position is your date. I would start somewhere here around 80 to 90. I think it's going to be around those numbers. And then you're going to have to run it, see what it gets you and see if that's the date. And if it's not, you have to adjust these numbers to match just that date. But that's what I would do, at least to get you going here in this case.
Hey, Dr. Bastos, I found a path, a trend on the data. All those as like a number 273 when the path ends. You can use the 273 as a set and do the same way you did. Also works.
Nice.
Yeah, 273 before the 2/4. It also works. All the files had the same 273.
So if you give,
I don't know if it's the right, but it worked here.
so maybe if you give 273 / as your pattern or as your separator.
Mm-hmm.
Okay, yeah, so nice. That's a good solution as well. Yeah. Yeah, that would also work. So if we just did that, I just want to make sure it works on my side. I guess on my side, it's not going to work as well because I have the double /.
You have the double. Yeah.
Right, but
If
in
you
your,
had the double there,
yeah, that's a great solution. Thanks, Vinicius. Thanks for sharing that. Yeah, so if you did have the issue, you can just change your separator to 273 /.
Yeah.
That would be your path. Yeah. Awesome. Well, let me save here, and I do want to tell you all one thing. So we're gonna finish this script here on Wednesday for sure. We may have some extra time, so we may start another script. But the goal here is, so we pulled imagery for 1 year, we process it. At the end of the script, it's gonna be processed. Then we want to do the same steps for the 2 other years, so 2019, 2020. However, even though our field, I was doing the math, is just 0.4 square kilometers, and you all have a quota of 5,000 square kilometers per month on Planet. So we should not have used all of our quota in this exercise. But it did happen. I did get your email, Doug, and that's what happened. It happened on my side as well. So it probably happened for everyone that if you go on your Planet account, your quota for this month is completely used already, which means it will not allow you to pull more imagery. That is an issue because again, we pulled, so our field's about 0.4, I mean, you can do that here. So 0.4 square kilometers. If we just multiply that by 47, we used a quota of about 19 square kilometers and we have 5,000. So I'm not sure why on Planet side it is thinking that we're taking up all of our quota. I reached out to them today. I'll see if it's something that the code that I develop could be improved, or maybe on their side is, I mean, I'm not sure what's going on, but I got in touch with them. I want to see if we can fix that because we all want to be able to pull again from the same sites for 2 more years. And right now, I don't think any of us can because we all went over our quota. So I'm working on that to try to. Yeah.
I was gonna say, I was able to pull all like the imagery for 17, 19, and 20.
Okay, nice.
I was able to get all of mine downloaded.
Awesome. That's good to know. Because and that was Clint, right?
Correct.
Okay, so Clint, let's do this. I'm gonna try to work this through with Planet. And if for some reason I can't, I will ask you to share the imagery with me so I can share with everyone else. Because really the script is gonna work if you have the quota, right? And I don't want us to get stuck and not be able to pull it just because for some reason we went over the quota. So let's plan on that. If Planet has a solution for us in the next day or so, then we'll be able to pull for the other sites. If not, then I'll ask Clint to share his imagery with me and I'll share with the remaining of the class. All right, any questions? All right, so if you have no questions, then we're gonna wrap up for today. On Wednesday, we're gonna finish the script and perhaps do the same steps for the other 2 years and keep moving in our exercise. All right, thanks everyone. See you on Wednesday. If you're still having issues with the path, send me an email with the Zoom link and we can connect to go through that. But if you're able to troubleshoot it based on the tip that Vinicius found, then I think things are resolved. All right, thanks everyone and see you Wednesday.